Alright team, today we're going to look at arithmetic progressions, and we're going to look at these progressions by investigating two formula that you need to be aware of and able to use in Pure Maths 1 exams. I'm pretty sure that the formulas will be provided on the formula sheet, although I will check that, so don't take me as that is gospel yet. But it's the ability to use them that's going to be important. So let's talk about, first of all, this one here, the nth term formula. We write it as a plus n minus 1 d. Now what is a? A is equal to the first term of the series. N is for the nth term, obviously, and d stands for the difference, the common difference between each term. Now let's investigate this formula using question 1 here. The ninth term of an arithmetic progression is 8, the fourth term is 18. Find the first term, which is a, and the common difference. Okay, so what I'm going to do here is I'm going to say, well, I know the fourth term is 18, and I know the eighth term, so I don't know 5, don't know 6, don't know 7, don't know 8. Oh, I do know the ninth, and the ninth is 8. You can see it's going down here. Now, how many differences have we done? Each time we go up one n value, we're going to change. There's going to be a difference between each of these terms. You know, it's common in arithmetic sequences, so it's the same each time. So I've got 1 hop, 2 hop, 3 hops, 4 hops, 5 hops. Okay, so I've got 5 differences. So I would say 5 differences is equal to, and what have we gone? We've gone from 18 to 8. So we've dropped down 10. So I'd say 5 differences is equal to minus 10. And therefore D is equal to negative 2. So I've got the common difference now. Now I've got to find the first term. So to find the first term, I'm going to use the whole formula here. A plus. Now I know that my fourth term, so I'm going to use a 4 here. I know my fourth term is equal to 18. So I'm using the formula up here and just inserting the numbers that I do know, and then I can rearrange this to find out what A is. Now if I do this, I will find that A is equal to, now let's see, minus 2 times 3 is minus 6, but then I add that on, so A should equal to 24 in this case. Okay, let's have a look at number 2. This time we're doing using the sum formula. Now let's have a look at that, the sum formula. The sum of an arithmetic progression can be written in 2 ways. Sum of n is equal to n over 2 plus into a plus l, or the other option is, it could be n over 2 into 2a plus bracket n minus 1 bracket d close brackets. Now the only other thing that we don't know here is L. So what's L? L equals the last term, obviously in a finite series. Okay, the sum of the terms of an arithmetic progression is 38.5. The first term is 1, and the last term is 6. Find out how many terms there are in the arithmetic progression. So we're going to be using this formula here. We know that Sn is 38.5, so I'm going to go 38.5 equals. Now, what else do I know? I know that the first term is 1. So I'm going to go n over 2, because I don't know n yet. But I do know A is 1. And I do know the last term is 6. Alright, so I've got 38.5, and I'm going to times it by 2, and that will give me n into 7. Right, 6 plus 1 is 7. Okay, so if I get 38.5 times 2, 76, so 77. equals 7n, and therefore n must equal 11. So there are 11 terms in this arithmetic progression. Let's move on to number 12 now. Find the sum of all the odd numbers between 20 and 100. So we could do it the slow way. We got 21 plus 23 plus 25, okay? But I'm not going to do that. I'm going to use, again, the same formula here. I know my last term is going to be 99. I want to know Sn. I know A is 21, and I know L is 99. What is N going to be? Well, all we need to do is figure out how many numbers there are, odd numbers there are between 21 and including 99. So you could go 100 minus 20, and that gives you 80. And so obviously half of those are going to be odd numbers. So I'm going to say N is 40. So I'll pop that into here now, 40. And so my next line is going to be 40 over 2, which is 20. And then 21 plus 99, well, that's going to be 120. And when I multiply that out, I'm going to get 2,400. Okay. Let's take a look at the last one here, number 19. The first four terms of an arithmetic progression are 2, 6, 10, 14. Find the least number of terms needed so that the sum of the terms is greater than 2,000. Right, in this case, I'm going to use this formula here. Okay? Alright, what do I know? I know A is equal to 2. I know the common difference each time we're going up in fours, so D is 4. So, I want 2,000 is less than, instead of equal to, because it says sum of terms is greater than 2,000, is less than, now I'm going to go n over 2, because I'm trying to find n in this case, and I'm going to put my square bracket, 2 times a, which is 2. I'm going to go plus n minus 1, bracket, d, which is 4. I'm going to close my bracket. Now let's start simplifying this. So my next line, 2,000. Okay, I'm going to have n over 2. I'm going to have my square bracket here. I've got 4 plus 4n minus 4, close bracket. Next line, 2,000 less than n over 2, and I've got times 4n, because obviously this 4 and this minus 4 are going to cancel each other out. Next line, 2,000 is less than, now when we work this out, we're going to have 2n squared. Next line, 1,000 is less than n squared. So n is equal to the square root of 1,000. Square root of 1,000 is 10 square root 10, or 31.6. Now, let's think about that. That means that when n is 31, or the 31st term in the series, that's not quite going to be 2,000. So that means it's our 32nd term that will make us have a sum greater than 2,000. So I would write the 32nd term. You can always check if I'm right on this one, because you could find out what the 31st term is. So I'm just going to do that in red over here. The sum of the 31st term, we could use this formula again. So we could go 31 over 2 into 2 times 2 plus 30, so we're doing 31 minus 1, and then the difference is 4. Now when we do this, what do we get? Let's just do this quickly in the calculator. 31 over 2 multiplied by 4 plus 31 minus by 30, 120. Okay, and what do we get? Well, we get 1922. So there you have it. That's just a brief introduction of a couple of the kinds of skills that you're going to need to work through this exercise. Do let me know if you have any trouble. I'm totally happy to help. And good luck with the exercise, guys.